So in this video, we're going to talk about now how to write equivalent rational expressions with the desired LCD. So in my previous video, I talked about how to find the LCD between different rational expressions. So you should already be kind of okay with that before you start this video. So in this video, we're going to work on finding the LCD, and then we're just going to write two equivalent, I said fractions, I meant rational expressions with that LCD. So let's just jump right into it. Okay, so the first thing that we're going to do, and I would strongly encourage you to pause here and just make sure that you're good on this, is just find the LCD between these two denominators. So pause here, hit play when you think you've got it. Okay, so 15 is 3 times 5, 9 is 3 times 3. So for the number part of my LCD, so they both share this one factor of 3, and then they have this other factor of 3 and 5 not in common. So this is going to be an LCD of 45. Okay, so now we have to bring in the variable part. So this will be 45, and then let's see, I take the highest exponents. This will be 45x cubed y to the 5th. Okay, so let's note this. Let's see, actually, I think I'll just leave everything up. Let's see, I'll get rid of this part right here, maybe. Okay, so now to finish this, I'm going to take each one of these and rewrite with the desired LCD. Tripping over my words here. Okay, so I have 15x squared y to the 5th. So first things first, so if you remember how to do this with fractions, I have to think about what do I multiply 15 by to get to 45. So that's going to be 3. But now I also need to get from, I need to have x squared y to the 5th. Or sorry, I need to have x to the 3rd y to the 5th as my LCD, and I have x squared y to the 5th. So what am I missing? In this case, I have x squared, I need it to be x to the 3rd, so I need to multiply by one more factor of x. And whatever I multiply by the bottom, I multiply on the top. So I can multiply those things together now, and I get 45x cubed y to the 5th. So there's my first fraction. And so that's the idea behind this. So maybe you could pause here and try to do the other one. We'll just check your understanding. Hit play when you're ready. So let's see, for this other one, so I'm just going to focus on the denominator for now. So it's what do I have to multiply this by to get to the LCD? So for 9, I have to multiply 9 by 5. I have the x cubed, but I need 3 more powers of y to get to y to the 5th. Whatever I multiply by the bottom, I multiply by the top, and then I just multiply everything straight across. So this is going to be 20 y to the 3rd on top, and then 45 x cubed y to the 5th. So there you have it. Okay, so let's take a look at doing this now with like polynomial bases. So first of all, what's my LCD in this case? I've got x plus 3 and x. Well, we talked about this in the other video. The LCD here then is just going to be x and x plus 3. What I want to focus on with this is kind of how having a polynomial can add in another layer of difficulty. So if I have 5 over x plus 3, so what do I have to multiply the denominator by to get to the LCD? I have to multiply it by x. Whatever I multiply by the bottom, I have to multiply on the top. So this first fraction is going to be 5x over x times x plus 3. Now I'll give you a little trick here. So in general, when we're working with these things, we don't have to multiply the denominator together. It's usually just the numerator. So if I do that for the next fraction, so I've got 4 over x, so now I need to multiply this by x plus 3 on top and on bottom. Okay, so what I'm going to want to do, and you'll see why I want to do this in the next video, but what I want to do is I do actually want to distribute this 4 on the top. So force yourself to get in the habit of just distributing the top part. The bottom part you do not have to distribute. And like I said, you'll see why that is once we start adding and subtracting these things. But that's what it's going to be for now, so we're all good. Okay, So now let's just work our way up to something a little bit more tricky. So now I've got these, quadratic polynomials. So pause here. Why don't you try this totally on your own? Hit play when you think you've got it. Okay, so first things first, I'm going to just show you what the factorizations are because I'm assuming you already worked those out. So the first one's going to factor x plus 6, x plus 3, and the other one's going to factor x plus 3, x plus 2. So just make sure that that's what you wrote down. So my LCD then is going to be x plus 3 is what they have in common, and then x plus 6 and x plus 2. Now in this case, I'm going to need a little bit more room. So what I'm going to do is I'm going to make some space. Okay. So now when I write out these fractions, what I'm going to do is I'm actually going to rewrite them with a factored denominator. So I'm going to write this out as x plus 6, x plus 3. And then that just makes it easier for me to figure out what I need to multiply by. So what is this denominator missing that the LCD has? It's missing the x plus 2. So I'm going to multiply the top and bottom by x plus 2. And like I said, you want to get in the habit of distributing the top, so you do actually want to multiply out the top. So if I multiply these things together, I get x squared plus 2x, and then the denominator, I have all this stuff. Okay, and if we do the other one, so let's see, again, I'll just write this factored out, so then I can see that this clearly needs to be multiplied by x plus 6 on top and on bottom. So I'm going to multiply out and I'm going to distribute this 2 to both of these factors here so that this becomes 2x plus 12 and then all of this blah, 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 blah. It's a lot of writing. Okay, so let's make sure that you've really got it now. So now I've got 3 fractions. So if you can do this, you've probably got a pretty good handle on it. So pause here, give it a go. Try to write all your equivalent fractions. Hit play when you're ready or if you're stuck. So the first thing I know I need to do is I need to write out the factored form of all of these. So I'll just flash that on the screen. Okay, so these were a little harder to factor, I think, in some ways, or maybe they mess with your brain a little. They kind of mess with my brain. But so for this first one, so I can factor it just out a GCF of 5x. So then this will be x minus 6. This is slightly harder to factor, and it factors 2x minus 5, x minus 6. And then the last one, so I can factor out just x, and that becomes 2x minus 5. So my LCD then is going to be, so now we've got to be careful. So I've got 5x and x, so those two things need to come together. So this will be 5x. And then the 2x minus 5 and the x minus 6. So those are all the parts that are going to make the LCD. Okay, so now I'll clear some space. Okay, so what do we multiply each by? So I'm going to write out the factored form to help me out here. Okay, so for the first fraction, so I've got 5x and the x minus 6, so I need to multiply by the 2x minus 5. So 2x minus 5. 2x minus 5. So this is going to become 2x squared minus 5x on top. And then 5x, x minus 6, 2x minus 5. Okay, for the next one, so in its factored form, this was 2x minus 5, x minus 6. So if this is what I have, then I need to multiply the top and bottom by 5x. And then I can distribute, so this becomes 5x squared minus 10x on top. And all of this other blah, 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 so on and so forth stuff on bottom. And let's see, I'm going to cram in this last one. I should have written just a little smaller, sorry. So this is going to be factored. Let's see, I factored out the x. So this is 2x minus 5. So what do I need to multiply this by? So you want to be careful with this last one. So I need to multiply both by the 5 and the x minus 6. So this will be times 5 x minus 6. Okay, so 2 times 5 is 10. If I distribute 10 into this x minus 6, this will become 10x minus 60, and then all that other stuff. Okay, so hopefully you feel like you've got a decent idea now of how to rewrite these rational expressions with these LCDs. And yeah, it can take a while just to kind of write everything out, but really try to practice good habits with this, because if you really fly through it, sometimes you're going to just make a mistake. So be careful with that. If you feel like you're kind of struggling with this and you want to see more examples, I've got a lot more. So I encourage you to check out my other instructional and example videos. This is kind of something to get you started, and then you can fill in more as you need it for how you think about things. Okay, so that brings us to the end of this video. Please consider hitting the like button or subscribing to the channel. Thanks for watching. I'll catch you guys in the next video.